Assalamualaikum students. We study derivatives. So today we study antiderivative or integration. It is inverse of derivative. So it has two types, indefinite integral and definite integral. If you have no boundary, it starts infinite points. It start and end to the infinite points which we do not know the ending points. Then we do not know the starting points and ending points, then it is called indefinite integral. If we have interval like AB, starting point and ending point, then it is called definite integral. This is integral. This is limits of integration. One is ending point or upper limit. 0 is lower limit or starting limit. This function, which function we integrate, it is called integrand. Dx is called differential. This sign become integration sign. This integral and dx is called integration sign properly. When we integrate, we apply integration sign and dx differential sign. This is limiting function, limiting points 0, 1, upper limit, lower limit. This is integrand. This is the function which we use in the integral sign, or we want to integral sign. This is the basic formula of integration. Integral xn dx equals to x power n plus 1 over n plus 1 plus c. This is not for n equals to 1 minus 1, because when we put minus 1 it becomes 0 over 0. X power 0 over 0, which is infinity. This is not in the integral sign, so we cannot put minus 1. We put minus 2, 2, 1, 3, any number, but not minus 1. All numbers, all real numbers you can put here, but except minus 1. This is some functions. Integral of constant is ax. Of variable, if we have x, then it become x square over 2, because 1 plus 1, 2 over 1 plus 1 is 2. Square, if scaling function you have, then plus 1, 3 over 3. Power, which power become here, which then it divide in the denominator. Reciprocal, if we have 1 over x, it become ln x. Exponential, ex equals to ex, ax equals to ax ln a. Ln x, the integration is x ln x minus x plus c. Trigonometric functions, cos has sine, sine has minus cos. Cosecant square equals to tan x, and many other types of trigonometric functions have integral. Multiple of constant is cf f of x equals to c f of x. Power function, this is power rule. Integral xn dx equals to x n plus 1 over n plus 1 plus c. Sum rule, difference rule. Find the antiderivative of the function f of x equals to 1 over x power 3. Then we have example number 1. Function equals to 1 over x power 4. Firstly, we notice the derivative of the function is of 1 over x cube. Then it taking the derivative of this, so it become x power minus 3. Then derivative is minus 3 x minus 3 minus 1. In derivative we minus subtract minus 1 from the power, so it become minus 3 over x power 4. This is the derivative. but we're taking the integration of this function, then f of x equals to power above equals to f of x equals to, if we take x4 in the numerator, then it becomes x minus 4. Minus 4 we use power rule, then it becomes minus 4 plus 1, which is equals to x power minus 3 over minus 3. You remember the power rule function, power rule, x n plus 1 over n plus 1. So it becomes x power minus 3 plus minus 3 over denominator. In denominator we have minus 3. So we take x function in denominator, power become positive. So it is, answer is minus 1 over 3 x power 3. We can check this by the differentiation. Equals to 1 over 3 x cube equals to 1 over 3 x power minus x minus 3, taking derivative of this, then equals to 1 over 3 multiply minus 3 x4, then it is equals to the function. Mainly you have to do this point, not this and this. This is for the previous knowledge and above for the knowledge, not for the question. It is important part of this. This is the important part, because f of x equals to, we find the antiderivative. So it is f of x equals to minus 1 over 3 x cube. Like we have taking then we take f of x equals to, it become x power minus 4. Then we add 1 over minus 4 plus 1. We are using power rule, so it become x power minus 3 over minus 3. Our answer is minus 1 over 3 x power 3. So this is the main point you have to do in the antiderivative. This is not for the knowledge, this is doing for the derivative, then find integration, then we justify this. This all procedure is for the integration. Just like you can see, this is the function f of x equals to 2x. We are taking integration of this function. It becomes integral f of x dx equals to integral e power 2x dx. Then ex value is, integral is ex. Integral value is same as in exponent ex equals to ex, but here you have 2, so it divide in the with this, it become plus c. This is the integral of f of x equals to e power 2x. This is the integral. Then you have to see this, f of x equals to 1 over radical x power 3. Function is this, so we have to find integral of this dx equals to this. Mainly you have to do these points. This is for the knowledge. You have want to cut this, you can also do this. You also cut these points, but you have to do these points for the integration. F of x dx equals to 1 over x power 1 over 3. We know the power of radical cube is this, so it becomes this. We taking x in numerator, taking this, it become integral x power minus 1 over 3 dx. Then we add 1 here, and in denominator it become x minus 1 over 3 plus 1 over minus 1 over 3 plus 1 plus constant. When we are doing indefinite integral, we have to use this because we do not know the limit, so we have constant. When we see derivative of constant is 0, so we put constant here, so it becomes x power 2 by 3 over 2 by 3 plus c. So answer is become x power in root, which is equals to cube, 1 over cube equals to radical cube x power square over 2, 3 multiply in here, so it become answer. Answer is 3 cube radical x square over 2 plus c is the answer. You can see the next example. F of x equals to e power minus x. So f of x, we know the integration of a power x dx equals to a x ln a. Ax, the integration is ax over ln a. So it become a is any constant, so ax 3 power minus x over ln 3 plus c is the integration of this function. You can cross these points and these points. You only have to do these steps, or you can properly do this step. Initial value problem. In initial value problem, you have condition like this: fy of x equals to 7. You have to know this: f of x equals to y naught. This is the value of x equals to 3 here, and y naught, y value is 7. So y of x equals to y. So x value is 3, y value is 7. So you have the function here, this, which is derivative dy over dx equals to x square minus 1. Taking integration on this point, so it become x square plus 1 over 2 plus 1, which is equals to x cube over 3 minus constant value integration is x plus c, like this. This is the integration of this function. Then putting the value of x equals to 3, put 3 here and here, equals to, this is equals to y, because dy over dx integration is y. So it become equals to 7. So 3 cube over 3 minus 3, putting the value of x plus c, equals to putting the value of y, which is equals to 6 plus c equals to 7. Then equals to c equals to 1, because 6 minus here, then it becomes c equals to 1. C value putting here, it become y x cube over 3 minus x plus 1. This is the answer. Then we have second initial point. Initial point means it is condition on 1, x value is 1. You have next condition f prime of x 1 equals to 2 or anything. Its condition on x has the same point. If x change the value here and here, then it become boundary value problem. But here we have x single answer, so it is initial value problem. X value is 1, y value is 5. So integration of this become x power is 1, so plus 1 over 1 plus 1, it become 2x square over 2 plus minus 1 over x square taking upside, it become x minus 2 plus 1 over minus 2 plus 1. So it become x equals to minus 1 over minus 1. So it become positive, because minus minus positive 1 over x. Taking minus here, then it become positive 1 over x plus c. In indefinite integration we can use plus c. Then putting the value of x equals to 1 and 1, it become 1 plus 1 plus c, and y value is 5. It becomes c value is 3. So y equals to x square plus 1 over x plus 3. Initial value problem here. It is the 1 over x integration is ln x. You can see these points from the rules of integration we discussed before. All the rules. Then it become x is here is x plus 1, so it is become ln x plus 1. So putting also the value of x equals to 1, so this is here ln x plus 1 plus c. Putting the value of x equals to 0, when you put 0, it become ln 1 multiply with 2, c value is 2, y equals to 2. Putting the value of 2, then you get c equals to 2. This is the main particular solution of the equation. This is definite integral. This is the definition of definite integral. Limit, lower limit is a, upper limit is b. Integral f of x dx, which is equals to integral function. Firstly do integral, then put upper limit minus lower limit, just like integral 2 to 4 x square plus 1 dx. Simply integrate this, it become x cube over 3 plus x. Putting the limits line on the whole function. Lower limit is 2, upper limit is 4. Just like a equals to this and b equals to this. This is equals to b and this is equals to a. So it become, putting the upper limit first in this function, it become 4 cube over 3 plus 4 minus x cube. Lower limit 2 cube over 3 plus 2. Last value, then we simplify this and last value is this. In this we cannot put plus c because we find the value, simple value. But in indefinite you can put plus c, integration of the function, then plus c. But here in definite integral we then do not put plus c. Example number 2. cos x dx equals to integral 0 to pi cos x integration is sin x, upper limit lower limit, putting the upper limit first, sin 180 is or sin pi equals to 0 and sin 0 is also 0, so it becomes 0 minus 0 equals to 0. Average and mean value theorem. If f is integrable on AB, average value of the function over the integral AB is given as f AB. AB means average equals to 1 over b minus a integral AB f of x dx. This is the average mean value theorem statement. Applying mean value theorem for integral f of x equals to 4 minus x, then where f actually takes on this value at this point, taking this in here and it is taking integration of this function, it becomes 4x minus x square, putting the limits, lower limit is 0, this is the value of a and this is the value of b. So putting value of b, which become x power x4, our value is x4, after integration it becomes x4 over x square by 2. Firstly put b value, x multiply 3, it becomes 12 minus 9 over 2 minus lower limit, it becomes 0 and 0, so it becomes only 12 minus 9, which is equals to 5 over 2. Then multiply with this number, just a minute, hold on, it solves, then it becomes this value, then multiply with 3 because 1 over b minus a is multiplying with the integration of the function. So our last value is 5 by 2. So this is the average value of the function f of x over the interval is 5 over 2, and graph will be like this, 5 by 2 on this point and finding the value of x, which is equals to x 3 by 2. Show f of x is continuous on the interval a is not equals to b, and if function is equals to 0, f of x equals to 0 at least 1 in the graph. Because this is continuous and this is equals to 0, so our value, this value is 0 at least on one point on the given interval which is closed. So we put 0 because f of x is 0, then we put here 0, 0 integration is 0, 0 multiply with this, it is equals to 0. This is by mean value theorem. F assume this value at the point C belongs to AB. This is some references for this. Thank you. If you have any question, you may ask.